All right, so our last reaction involving carboxylic acids is the neutralization of carboxylic acids. All right, so here is our neutralization reaction. This is something we've definitely seen before. That process is metathesis. We have looked at this already. I know it's been a while. And then our reaction name is neutralization. And if you can remember back from 1201, we talked about neutralization reactions. We said that these involve an acid reacting with the base to give us a salt, an ionic compound, and water. And that's exactly what we've got going on here. So we are taking ethanoic acid, common name acetic acid, this is vinegar, essentially, reacting this with sodium hydroxide. Now, notice what happens here. And again, this should be a refresh and a review. The acidic hydrogen reacts with the hydroxide from the sodium hydroxide to give us our water. Now, when this happens, I end up with the acetate ion from my acetic acid, or my ethanoate ion, and my sodium ion. This makes this neutral, right? So I'd have a neutral pH, or pH of around 7. Now, as our organic acids get larger, that R group is going to get larger. So in this case, we have a relatively small R group. And you can see in the mole view underneath the picture there, you can see a very uneven distribution of electrons. But even with this small molecule, you can still see that that section that I've pointed the arrow to is relatively neutral. As that area gets larger, it's going to become much more difficult for those acids to dissolve in water. They're just far too big. That nonpolar region really starts to take over. If we have these acids undergo a neutralization reaction, their salts become incredibly soluble. And this is what we call the solubility switch. Most biomedical compounds are actually salts, organic salts, and they are this way so that they can actually dissolve in our bodies and in our system. And we are definitely going to be seeing this more and more as we move through the course.